welcome to our channel Jayadithya Math Tutorial. We are doing a series of 10th class mathematics. As a part of this, we are now in the chapter similar triangles and we are now in the exercise 8.3. In the previous class, we have done two important problems which may have a scope of getting in 4 marks, and now we are going to solve the remaining problems which are very important under 2 marks. These problems are related to areas of similar triangles. So here you need to understand one statement: ratio of areas of two similar triangles will be equal to square of the ratio of their corresponding sides. So this is very important. So we are going to discuss the problems related to this principle now. So do watch it till the end. This exercise is very important. What are the problems we are doing now? It has a scope of getting in your public examination. So be careful and be cautious, and how we are applying the sides, how we are taking the sides, you should focus there. Okay, without wasting any time, we'll be entering into our class. But before that, if you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends, and don't forget to hit the bell icon. Okay. Right, Nana, look here. This is the fourth problem of your exercise 3, and here he has given area of, the triangle ABC is similar to triangle DEF. Triangle ABC is similar to triangle DEF, and he has given some dimensions here, that is BC is equals to 3 centimeters, EF is equals to 4 centimeters, and area of triangle ABC is 54 centimeters square, and you need to find area of triangle DEF now. So this is very simple problem and also very important problem now. So don't miss this problem. This problem is very easy and it has a scope for getting in 2 marks. Okay, what we have discussed earlier or in previous class are for 4 marks, and these problems will be coming for you in 2 marks now. So don't miss this one. So this is very simple. So what is our statement here? Ratio of areas of two similar triangles will be equal to square of the ratio of their corresponding sides now. So here we have the dimensions of BC and EF, and both are the corresponding sides. So I have taken BC by EF. You can also take AB by DE if those sides are given. Here I have the sides for BC and EF. So I have taken BC by EF whole square. Substitute all the values. This is 54, and area of triangle DEF you need to find out. What is BC here? That is 3, and EF is 4 none. So this is whole square will be there. 54 by area of triangle DEF, which is equals to how much? That is 9 by 16. That is 9 by 16 here. So simplify this one. 9 ones are 9 6 are you can do. So area of triangle DEF will be equals to how much now? So if you bring this one and 16 to this one, that will be 6 into 16. So area of triangle DEF will be equals to 96. And what are the units here? Centimeters. So you should take centimeters square now. Why? Because it is area. You should be careful with centimeters. Why? Because problem is very simple and you can get it easily. So you should also mention the units here. Okay. Let us go for the next problem. The next, right, Anna, look here. The problem is, this is the fifth problem. In a triangle ABC, he told that PQ is a straight line meeting AB in P and AC in Q. So PQ is a straight line. It is meeting AB in P and AC in Q. AC in Q. So here PQ is a straight line. If AP is 1 centimeter and BP is 3 centimeters, AQ is 1.5 centimeters and QC is 4.5 centimeters. What we need to prove here is area of triangle APQ is equals to 1 by 16th of area of triangle ABC. You need to prove that area of triangle APQ is equals to 1 by 16th of area of triangle ABC. So how to prove this one? So here he has given two areas, so you can understand that ratio of areas of two similar triangles will be equals to square of the ratio of their corresponding sides. So you should try to bring out the corresponding sides here. Before that, what we need to do here? Here he has given some dimensions. So let us check whether PQ is parallel to BC or not. If PQ is parallel to BC, then our problem will be very simple. So how to check this one? By using converse of basic proportionality theorem, you can check that whether the line is parallel or not. For that reason, what you need to do? So I am taking AP by PB ratio now. AP by PB, how much it will be? That will be 1 by 3. Okay, let us take this as equation 1. Also you check the ratio of the other side, that is check for AQ by QC. AQ by QC. So what happens here? That will be 1.5 by 4.5. If you cancel this one, 1.5 ones are 1.5 3s are. Again you got it as 1 by 3. So that is equation 2. So from 1 and 2, what can you say? From equation 1 and equation 2, so here the ratios are equal right now. So write this one, AP by PB is equals to AQ by QC. If the ratios of two sides are equal, then what can you say here? By converse of basic proportionality theorem, PQ is parallel to BC. So by converse of basic proportionality theorem, what can you write, Nana? PQ is parallel to BC. PQ is parallel to BC. After this, what you need to do is show that these two triangles are similar, Nana. For that reason, what you will be doing here, as we have done in our previous class, just see here, angle P will be equals to angle B. Why? Because corresponding angles. And also angle Q will be equals to angle C, that is also corresponding angles. Or else you can take angle A is equals to angle A, that will be common angle. So if you show any two angles, that is enough to show that triangles are similar. So for that reason, what I am doing here, let us see here. So in triangle APQ and triangle ABC, in triangle APQ and triangle ABC, so what can you say here? So angle A is equals to angle A, that is common, and angle P will be equals to angle B, that is corresponding. That is corresponding angles now. So you have shown two angles, that is enough actually. So by AA similarity, what can you say that? Area of triangle APQ is similar to area of triangle APQ is similar to triangle ABC. So after that, what we need to do? So ratio of areas of two similar triangles will be equals to square of the ratio of their corresponding sides. So for that reason, let us take the ratios here. We want area of triangle APQ, right now. So I am taking here area of triangle APQ in the numerator by area of triangle ABC, which will be equals to square of the ratio of their corresponding sides here. So what are the corresponding sides? AP and AB are corresponding, right now. AP and AB will be corresponding. So square of this ratio will be equals to ratio of the areas of two similar triangles here. So write this one, area of triangle APQ by area of triangle ABC, which is equals to how much? AP is nothing but 1 by AB. AB will be how much? That is 1 plus 3. 1 plus 3 is nothing but that is 4. So you can write from figure. This is from figure. So now the problem is completed almost. So APQ will be by area of triangle ABC is equals to how much now? This will be 1 by 16. So take this to RHS. Area of triangle APQ will be equals to 1 by 16th of area of triangle ABC. That's all. So now our required proof has derived, right now. So problem is very, very simple. The first case is, first you check whether PQ is parallel to BC or not. After showing that PQ is parallel to BC, show that triangle APQ is similar to triangle ABC by using AA similarity. After showing that these two triangles are similar, take the concept here. That means the ratios of areas of two similar triangles will be equals to square of the ratio of their corresponding sides. So use this statement. This is the formula. By using the formula, you substitute all the values, then you will get the required answer. This problem is also very, very important. Let us see the last problem of this exercise, which is interesting problem. So here we will be applying two concepts at a time in order to solve this one. So this problem is important. So see here, Nana, here he has given the areas of two similar triangles are 81 centimeters and 49 centimeters. So he has given areas of two similar triangles is 81 centimeters square and 49 centimeters square, it seems. So what we need to do here, and he has told one more thing. Let us take like this. This is 81 centimeters square and this is 49 centimeters square. Let us take this triangle as A, B, C and this one as D, E, F. Okay. After this, he told that if altitude of the bigger triangle is 4.5 centimeters, if altitude, so altitude will be perpendicular to the base. Let us take the altitude as AX, and he has given the altitude here. Altitude of the bigger triangle is 4.5 centimeters. This is 4.5 centimeters. What is bigger triangle? The triangle which has more area will be the bigger. So I am taking there. And what you need to find here? You need to find the altitude of the smaller triangle. So I am taking the altitude of the smaller triangle as dy. I need to find dy now. So how to find this one? As we have discussed a concept in our previous class where we have discussed about perimeters problem. So in perimeter problem we told one thing, Nana. The ratios of perimeters of two similar triangles will be equals to ratio of their corresponding sides, which is again equals to ratio of their corresponding medians, which is again equals to ratio of their corresponding altitudes. That means corresponding altitudes ratio will be equals to corresponding sides ratio. Is that right or not? So you should understand in that manner. So let us see here. Let us understand this one. If triangle ABC and triangle DEF are similar, if triangle ABC and DEF are similar, what can you say here? Means perimeter of triangle ABC by perimeter of triangle DEF will be equals to ratio of their corresponding sides. So that is AB by DE, which is equals to, so these are the corresponding sides, and all the corresponding sides will be equal, and also these corresponding sides will be, ratio of the corresponding sides will be equals to ratio of the corresponding altitudes also. So this is equals to AX by dy, AX by dy. Clear? That means the ratio of corresponding sides will be equals to ratio of their corresponding altitudes also. Ratio of corresponding sides will be equals to ratio of their corresponding medians also. That means wherever you are using the ratio of corresponding sides, you can use the ratio of their corresponding altitudes here. Okay, just directly apply all this one. So here what we need to find here, area of triangle ABC by area of triangle DEF will be equals to square of the ratio of their corresponding sides, right, Nana? Square of the ratio of their corresponding sides, and this ratio of corresponding sides is also equals to ratio of their corresponding altitudes. So I can change here. Let us take this as equation 1, and now what can you write here? Area of triangle ABC by area of triangle DEF will be equals to AX by dy whole square. Can I write it or not? So here you put from equation 1. From equation 1. So when you are writing like that, you need not write this one. So ratio of corresponding sides will be equals to ratio of their corresponding altitudes. That is enough. Right now. So from equation 1. So substitute all the values now. Area of triangle ABC is 81. Area of triangle DEF is 49, which is equals to AX. AX is 4.5 by, you need to find dy, and here you have square now. So take square to LHS, that will be root over 81 by 49, which is equals to how much? So that is 4.5 by dy now. That is equals to 4.5 by dy. So if you simplify further, what happens here? Root 81 is how much? Root 81 is 9 and root 49 is 7, which is equals to 4.5 by dy nana. Okay, so here you can observe here I am cancelling like this. 4.5 ones are 4.5 twos are. So what is dy here? Dy becomes, when it 7 comes to the numerator and 2 comes to the denominator, so dy value is 3.5 centimeters. So here what are the concepts we have used? The first thing is the ratio of corresponding sides will be equals to ratio of the corresponding altitudes is one concept, and ratio of areas of two similar triangles will be equals to square of the ratio of their corresponding sides. First we have taken corresponding sides and then we have replaced with corresponding altitudes. Then we have substituted all the values here. Okay. So you only write this one. If two triangles are similar, ratio of their corresponding sides will be equals to ratio of their corresponding altitudes. If whenever the problem is related to median, you can also substitute the median values also. So in this way, if you know the concept very well, then you can easily solve the problems. I hope you have understood these problems very well. If you have any doubts, you do comment in the comment section. Do watch the videos repeatedly and do practice repeatedly. Nana. If you practice only, then you can easily solve these problems. Okay. mainly focus on the model, not on the problem. Why? Because you will not get direct problem from the textbook. Clear? So for that reason, what you need to do, you should practice the model and how the question is asked. So you should focus there, and what figures we are taking, how we are taking the triangles, how we are using the parallelograms. So you should understand in that manner, and you should also keep in mind the statements. Whenever the problem related to perimeter, you can write directly ratio of perimeters will be equal to ratio of the corresponding sides. And when it comes to areas, ratio of areas of two similar triangles will be equal to square of the ratio of their corresponding sides, and ratio of corresponding sides will be equals to ratio of their corresponding altitudes, and ratio of corresponding sides will be also equals to ratio of their corresponding medians. So you should understand all these concepts. If you don't watch my previous classes, please do watch it, then you will be understanding clearly. If you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends, and don't forget to hit the bell icon. Do give your feedback. If you give the feedback, then we can change accordingly. I always welcome feedback. Okay, now if at all there are any problems, we can rectify them with your feedback. Thank you for now. Let us meet in our next class. Till then, bye.